What's up, Alge 1A? Welcome to our first video. We're going to start by solving systems of equations by graphing. This creates a couple problems for us. One, you're going to need graph paper. On the Canvas page, I did upload graph paper. If you have the ability to print it out, you can, of course, print out all you want. You will also need a straight edge of some sort. If you don't have a ruler at home, any side of a book or a box or anything that'll make your line straight will work. If you don't have the ability to print, somewhere in your notebook you should have a couple graphs on some graph paper. We've used plenty this year, so see if you can dig through and find some. The other problem it creates is I don't have a graph and I can't really get it onto the screen. So I'm going to do my best here. I'm going to talk about this real quick. We're going to explain it. It's a very simple thing to do. I think you'll be fine. I also, on Canvas, have uploaded a Khan Academy video where he walks you through the process, but I'm pretty sure I can explain it and you'll be okay. But that Khan Academy video is there as another resource. So let's talk. We'll make this as brief as possible and be done with it. So we're going to talk about a system of equations. So the first thing is, what is a system? Well, a system, very simply, is just like any other system. Like I'm sure in health class you talked about systems within the body, the nervous system, the respiratory system. And all that is when more than one thing works together to accomplish something. So we're going to have a system of equations. All this means is that we have two or more equations working together. And by equations, we're talking about linear equations. Now, let's refresh your memories about something. If we take an equation such as y equals 1/2 x plus 2, we've spent a lot of time with linear equations and we spent a lot of time graphing them. So my question to you would be, why do we graph them? Of course, I can't hear you, but I'm hoping that you said, well, Mr. Goodman, the purpose of graphing them is that we know that there is an infinite amount of solutions. There's an infinite amount of XY combinations or points that make this sucker work. And there's an infinite amount. They happen to have a constant rate of change relationship, and they form a line when we plot all of those. Now, we started by making XY tables, and we plotted a bunch and drew the line. Then we learned about slope and y-intercept, and it was a faster way to achieve that. But the whole purpose of graphing the line is that we show all the solutions that make this thing work. As soon as I add a second equation, for instance, if I were to add y equals 5/2 x minus 6, now what I have done is I now have another equation that also has an infinite amount of solutions. So this guy has an infinite amount of solutions. This guy has an infinite amount of solutions. There are a whole bunch of XY combinations that make this guy work and a whole bunch of XY combinations that make that guy work. When we're looking for the solution to the system, what we're looking for is we're looking for that value that makes both of them work. So our solution here is the values or the point that make both work. So I'm hoping right now you're thinking, oh, well, I got it. If I were to graph this guy, and of course, if you have a piece of graph paper, you can go ahead and do that. You would plot your y-intercept at 0, 2. You would then count your slope. Since it's positive 1/2, you would go up 1 and to the right 2, up 1 to the right 2, and draw your line. If you have the graph paper, do that now. Pause the video, do it. Then graph this guy on the same graph. He has a y-intercept of 0, -6. He has a slope of positive 5/2, so you will go up 5 and to the right 2. Count that twice and draw that line. What happens when you graph those, and I'm going to sketch a really terrible graph. I have one on paper here. I can try to show you. We'll see how that works. But if I were to sketch that, here's my 2. Go up 1, over 2, up 1, over 2. That would give me a line such as that. If I were to graph the 5/2 x minus 6, Go down here to 0, -6. I would go up 5 over 2, up 5 over 2, and keep doing that. 1, 2, 3, 4, 5 over 2. What I'm going to find out is that they eventually will cross. The point at which they intersect, that is your solution set. I've graphed them both here. I'm going to try to show you this. We'll see how that goes. So what I'm looking at there, I'm trying to see if it shows. Here's my y equals 1/2 x plus 2. Here's my y equals 5/2 x minus 6. When I graph them both, they eventually intersect, and they are intersecting at that point 4, 4. So that means that my solution to this system is 4, 4. That is the point that makes both of those guys work. That's it. That's all there is to it. Graph both equations, find the point of intersection. Now, this does lead to two possibilities that are odd. The first one would be if I had an equation like y equals 1/2 x minus 6, y equals 1/2 x plus 3. If you have a piece of graph paper, pause the video and graph them both. Hopefully you do. Once you have those graphed, come back on the video and we'll talk. So now that you have them graphed, we would take a look at them, and again, I'm going to make another terrible sketch. But I think you'll see something, or if you're not graphing it, you can probably follow along. But if I'm up here at 3 and I go up 1 over 2, I get a line similar to that. If I'm down here at 6 and I go up 1 over 2, I get a line similar to that. What happens is I create two parallel lines. And of course, if I'm looking for the solution for them both, I'm looking for that point of intersection. The problem here is they're parallel. They do not intersect. And as we know, anytime we're solving equations or system of equations, we have the possibility where there's no solution. So in this case, there is no solution. Which of course, remember our empty set possibilities, we can write it that way as well. Either way. Now the other possibility is usually one that comes a little bit more in disguise. So if I have something like, I don't know, y equals x plus 3, or I have something like, let's see here, 2x minus 2y equals -6. In this case, when I look at something like this, I have those two systems. This guy's not in slope-intercept form. So I will solve him for slope-intercept form. So I'm going to subtract 2x, and we did this many a time, so hopefully this is a quick refresher. I'm going to wind up with -2y equals -2x minus 6. I'm then going to divide by -2. Remember, we have to divide everything. And I'm going to wind up with y equals x plus 3. What I come to find out is they're the same equation. That means when I graph them, those lines will be right on top of each other, which means every point on those lines works. That means there's an infinite amount of solutions. So guys, that's it. I mean, that's all there is to solving systems by graphing. Graph both the equations, find the point of intersection. Two crazy possibilities. They could wind up being the same line and give an infinite amount of solutions, or they could wind up being parallel and they never intersect, which means there is no solution. I'm sorry, that's best I can do without being able to display a graph and holding up graph paper, but that Khan Academy video is there. You can take a look at that if you don't feel this was good enough. Also under Canvas is the Unit 13 worksheets. I believe also gave you a hard copy of that before we left. It's been a crazy 2 weeks. I can't quite remember, but I think I did. You can either print that off or use the copy I gave you. Go ahead and do 13.1, which is solving by graphing. If you have any questions, problems, concerns, email me. I'm hoping that, at some point I can figure out a way to get a graph displayed to you. If not, we'll figure it out one way or the other. If you have any questions, let me know. Remember, on Fridays, my plan is to go over any questions we have and make sure by Friday that we are all comfortable with everything we've done. So if anything's bothering you or anything's like not clear, let me know. We'll clear it up. Hope you do well on it. See you guys later.